In comparison to igneous rocks, sedimentary rocks, I find to be much simpler to classify. Part of the reason is that sedimentary rocks have only two textures. They have clastic texture and chemical texture. Clastic texture means that they are composed of pre-existing sediments that get cemented together. So that seems sort of understandable. The names for sedimentary rocks are also way simpler than for igneous rocks. And there's lots of additional tests that you can do for sedimentary rocks that are a little bit easier than igneous rocks. So let's get started. One of the things I usually tell my face-to-face students to do when they get a pile of sedimentary rocks in front of them is to make two piles. To make a pile of ones that look clastic and a pile of ones that look chemical. Well, obviously you can't do that because you don't have minerals in front of you. But what you can do, and this will help you when you go to identify the sedimentary rocks, is make that determination early. It makes your identification process go much smoother. So you start with something that is this, right? So this sample like literally looks like chunks of rock that are stuck together, right? So that ends up as a clastic rock. This looks like shells that are stuck together, clastic rock. This looks like granola, plastic rock. Or classic, not plastic. It's early. I've only had half a cup of coffee so far. So this rock looks like sand that's stuck together. Sand is a pre-existing sediment. That goes there too. Let's see. Again, this stuff stuck together, the end. Stuff stuck together, sand particles, the end. Sometimes, ooh, I'm looking for a sample. Here it is. Sometimes you will have mud, layers of mud that get stuck together. That can happen too. Mud is a grain size, mud is a particle, so that is plastic. So let's talk about your chemical ones. This rock, and for this sample, you kind of want to ignore the white business on it. Do you see how this has that sort of waxy texture? This is characteristic of a chemical sedimentary rock. So we're going to stick that in our chemical side. This one, do you see how there's like splotches of weathering and reaction? This is evidence that this rock has been chemically weathered because it's a chemical rock. So that's going to end up here. This one's kind of crystalline looking. That looks like chemicals and not stuff stuck together. That lives here. These last two are also chemical and it's harder to tell. But if you zoom in, what you'll see is occasionally you'll see a couple crystals. And I'm not sure that the camera is really picking these up very well. But when you're in doubt if something is chemical or clastic, you want to test it with acid. And in all your samples, I'll tell you whether or not they react to acid. If they react to acid, that means they're composed of calcite and they're chemical. This one also has that sort of dusty appearance, and that's because there's been chemical reactions that have occurred on the surface of this rock too. So this is also a chemical sedimentary rock. So if they look like they've been sort of chemically beaten down, or they look crystalline, they are chemical sedimentary rocks, especially if they react to acid. So those are the big textures. When we look at clastic rocks, we're going to be looking at grain size and sorting. So grain size is the particle size, and sometimes you'll see that rocks are composed of a variety of particle sizes. So if you look at this sample and this sample, you see that there's a variety of particle sizes here. If you have a variety of particle sizes, that's called poorly sorted rock, and it's poorly sorted by grain size. If you also look at these two samples, you'll see that in this sample to the right, or at least to my right, I'm not sure if I'm going to flip this video. In this sample, you'll see that the particles are rounded, where here the particles that are cemented inside this rock, like right there, are angular in shape. So this is they're both considered poorly sorted rocks. This one is composed of rounded sediment, and this one is composed of angular. A well-sorted rock is one like these two. So spoiler alert, these are actually the same type of rock, but they have different colors. So they're well sorted because they have all the same particle size throughout. They're different colors because they have different cements. Remember that sedimentary rocks are formed when sediment gets compacted and then cemented. And so in this sample, the cement is a hematite cement. So if you remember from minerals, right, hematite, it has that blood red streak. So that weathered or earthy hematite causes this particular sample to be reddish in color. And this has a more quartz-rich cement, so it's lighter in color and it's not red. So red, again, is supposed to tell you a little bit about the presence of iron in the rock. All right, sometimes you'll have really fine-grained rocks, and that's where you'll have layers of mud. And these particles, the particles that make up mud are called clay minerals. And there's actually a ton of clay minerals, but we just collectively call them clay minerals because you need really a special microscope to kind of identify them. This rock is sort of self-explanatory, so I'm not going to go into this too much. So that's your clastic stuff. You have to look at grain size, sorting, and a little bit of the minerals, but by and large, it's not too bad. So these are your chemical sedimentary rocks. The first thing you want to do, well, so this one is kind of self-explanatory. Once you read over the rock chart, I have no doubts that you'll be able to figure out that one. These samples, oh, you know what? I lied to you. This is not, whoopsie poo. Remember how I couldn't find the crystals? That's because there are no crystals. This is actually a clastic rock. I'm sorry. Oof. That was number 30 for when you're doing that. That was my bad. Okay. Other chemical sedimentary rocks. These two, you want to look at how they react to acid. So some rocks are going to react to acid right away, like there. And that is due to the presence of calcite. Oh, I'm sorry, I made you sit there the entire time. I thought I paused that. Okay, so other times you will have sedimentary rocks. I'm going to zoom in just a little bit, where they don't really react so much on the surface, or if they do, it's kind of a weenie reaction. Not a whole lot going on there. And then this should sound a little bit familiar. I'm looking for my glass plate real quick. There it is. Where if I take my glass plate, man, it's a little rough, and I make a little powder. My powder will react to hydrochloric acid, but not the rock itself, and that's due to the presence of the mineral dolomite, and that's a very similarly named rock called dolostone. So then finally you'll find this waxy rock doesn't react to acid at all, but what it does do that is different from the previous two rocks we talked about is that it does scratch glass. Let me make sure I got the right edge there. That, I'm not sure if you can see right there, definitely scratched the glass. And that's because this doesn't have any calcite in it, because calcite is softer than glass and this is harder than glass, which is why it just scratched. So the composition of chemical sedimentary rocks is really important for their identification. I think that you'll have a better time. I don't know if you loved igneous rocks, but I think sedimentary rocks are wildly identifiable. I think you'll have a good time. Good luck. The sedimentary rock chart works very similarly to the igneous rock identification chart, except that it's easier, which is nice. So let's take a minute to acquaint ourselves with some of the columns here. So here, the first column is the texture of sedimentary rocks. As I mentioned, there's only two. There's clastic, which your book sometimes calls detrital, but those basically mean the same thing. They being composed of pre-existing sediments. And then there's chemical sedimentary rocks, which also means non-clastic, so the opposite of clastic. Chemical sedimentary rocks form from precipitation of minerals from water. That often happens within groundwater. It can also happen in lakes, and it can also happen due to chemical reactions from buried organic matter like plants, you'll see. So after we have these two very basic textures, the next way that we sort sedimentary rocks is by their particle size. So if you have a very fine-grained particle, that means that you really won't be able to see individual particles. If you're familiar with sandpaper, sandpaper is the texture and size of medium-sized particles. Coarse-grained particles will be about the size of a bean, and bioclastic particles are when you have clasts or fragments of biological organisms, so usually that's shells. And then the same words sort of hold true for down below here. For composition, sedimentary rocks have much fewer minerals than you'll see in your igneous rocks. There are clay minerals, which are mud-sized minerals. There's quartz. Quartz can sometimes be found with orthoclays, so you'll see some of that pinkish salmon-colored mineral that's typical in orthoclays. Sometimes you'll see micas. The micas are generally your biotite and your muscovite. You'll see those sort of embedded within a rock called greywacke. When you're looking at your coarse grain rocks, they can both vary tremendously in their composition. When you look at the two coarse grain rocks that are clastic are called conglomerate and breccia. Basically, anytime you have a poorly sorted rock and it is coarse grained, if you have rounded particles, it will be a conglomerate. It doesn't matter what those particles are really made of. It can be any sort of rounded mineral that gets cemented together and it'll be turned into a conglomerate. Conversely, if you have angular particles, jagged edged particles that become cemented together regardless of their size, as long as there are a variety of grain sizes, you will get a breccia. So again, the composition for conglomerate and breccia are not particularly important. Composition for coquina, on the other hand, is very important because it's basically composed of shell material. When we get down into the chemical sedimentary rocks, composition is very important. So calcite, as a reminder, is a mineral that you learned about that reacts with hydrochloric acid. Dolomite is a mineral that will react only when powdered. Quartz does not react and is harder than glass. Calcite again reacts. And then when you have coal, coal is basically composed of recrystallized plant fragments over time. And you'll learn more about that in the lecture section of the course. The comment section here are really just sort of useful ways to identify these samples. And then finally, you have the names in this column here. So the first thing you want to do is determine if you have a rock that is clastic or chemical in nature, and then its grain size, and then you get into its composition just a little bit. I will say that this is usually less painful and one other than your igneous rock identification. And finally, there's one double in this set. So you will use one of these names on the far right more than once, but only one. And that's really all there is to it. And give it your best shot like you always do. Thanks.